Okay, I guess the recording is on. Right then?
Yep, it's going now.
Okay, thank you, Dan. All right. Good morning or good afternoon, everybody. My name is Ferenc Mihély. I work for the product architecture team, and I'm going to talk about API design today. Before I get into the details, I would like to give you a little bit of background about this presentation. About a year or so ago, we started looking into how could we make our public APIs better, how could we increase the quality of these APIs. And as part of this investigation, I went out and I read a number of books, about 24 research papers, and all the resources I could find Googling the internet. And today's presentation is basically and essentially an overview of what I learned in the process. I am not going to go into too much detail today because I also produced a series of 10 articles that summarize what I learned. So this is more like an overview. I would like to start by highlighting why it's important to study API design. The first thing that we discovered in the past 10 years or so is that the quality of the API has a big impact on the adoption rate of various software components. So the quality of the API has direct relationship to the degree of software use. And this was discovered by some of the largest companies, the Microsoft, the Sun Microsystems, the Oracles, the SAPs. All these companies have dedicated teams to do their API design. The other interesting thing about the quality of the API is the big of an impact it has on developers' productivity. We always kind of expected that it's quicker to develop with a good API than with a poor API, but we never really knew what the difference is. So by looking at some of the research, we realized that, oh, developers working with good APIs work actually 3 to 10 times faster. They are 3 to 10 times more productive. This is an amazing thing if you can increase productivity by designing better APIs. And you have research data to actually show that this is true. The other thing that makes API design more difficult than ordinary software development is that API is kind of a contract. You see, when we give an API to our customers, and the customers ask, oh, how long can I use this API? What do we respond? Do we tell them, oh, you can use it for a month, or you can use it until the next service pack, or you can use it until the next release? No, we usually tell them, look, you can use it as long as the product is supported, which essentially means many, many years. And that this kind of means that we cannot fix easily the mistakes we make in public APIs. We change internal implementation code all the time. If we make some mistakes, we will fix it easily in the next release. APIs being public, they're not that easy to fix. And this brings me to the last point that I wanted to make today, before I start, is that a lot of people think that releasing an API is basically just developing the code as usual, maybe providing a little bit better documentation, running a tool like Javadoc to produce a publishable version of this documentation and putting it online. And I hope today I will convince you that that's not enough. And let me continue with a pretty bold claim that I will try to substantiate. And this claim is that development that focuses on implementation does not produce good APIs. It actually produces mediocre to poor APIs. I have an example of an implementation class on the screen that kind of shows that it's abstract and it uses a deep inheritance and implements any number of interfaces. And it gives you a sense that classes like this must be hard to understand and it must be hard to use. But the claim itself, it relies on a lot of research that you can find on the internet. So the question becomes, if software development as usual produces poor APIs, how can we produce good ones? And the answer to it was discovered almost accidentally by a team of researchers conducting usability studies at Microsoft. So a typical usability study goes like this. You get a number of participants, you give them an API, you give them a task to complete, and you kind of watch them doing it to measure how much time it takes, you see how many errors they make, how many mistakes they make, how they correct it, and so on. So in a few occasions, these researchers gave the task to the participants, but did not give them the API. So they told them, make up the API as you go. Figure out what you need. So the participants did it. And then when they looked at the APIs they created for themselves and compared it to the existing APIs, the ones they were testing, they discovered they were very different. They weren't even, same classes or used for the same way. So the conclusion was that if you ask a developer to design an API he implements, then he will develop a kind of API. If you ask a developer to design an API that he's supposed to use and somebody else to implement, then they develop a different kind of API with a big difference. And I will try to illustrate the differences with this slide here. So we have these two perspectives that I call the implementation perspective and the coder perspective. The implementation perspective is what you expect. So for a class, it's the class definition, right? I have a class called document here, and I have 4 methods in it, right? The coder perspective is different. The coder don't really care about class definition. Like intuitively, we would expect they do, but they don't. The class definition is already finished. It's working, it's documented, it's work done. What developers really care about is the code that they are writing right now. So their perspective is the code they write. And let's compare the 4 methods from the 2 different perspectives. So the document class has a very straightforward method called getTag that returns a string representing the web 2.05 tagging assigned to the document. And look at the scenario when the coder needs to figure out if a document has been tagged with best practices. Using the getTag method, the code reads like if document getTag equals best practices. Kind of awkward. But if you provide a method called isTagged, which takes the string and returns a Boolean, then the same line of code becomes if document is tagged best practices. Reads a much more natural, closer to the, with the English. Or look at the last 2 methods. They do the same thing. They remove the tag. The naming is different. The one method is simply called remove. If you look at the class implementation, it's clear what you remove it because the parameter name is tag, so it removes the tag. And the other method looks a little bit redundant in the sense that tag appears twice in the name of the method and the name of the argument. But when you look at the implementation, the first name doesn't tell you what is being removed. You have document remove best practices. It doesn't tell you what is removed. If you use the second method, then it's very clear. You're removing a tag. So this is a very, very simple example of how, considering the coder's perspective, they make you change the way you design the API. So practically, what this means? This means that before even you start designing the API, you start writing client code for the various use cases that you are considering your API for. And I almost hear people objecting, saying, oh, this is a lot of waste of time, because you haven't even started writing the implementation, and you're already writing a bunch of code that you're not using, right? That is not entirely true. In addition of helping you design a better API, you can use this kind of client code for at least two other purposes. You can use it as tests, because that's what they essentially are. They show the functionality of the API, so you can test the API with them. And when time comes to develop the documentation, you have the code samples that you can use in the documentation to illustrate how the API works. So even if you spend time developing these code samples, that time is spent and is not wasted. When you look at these code samples, you can ask some really simple questions, like, is it the code simple enough? Is it intuitive enough? When I look at different use cases, is the code consistent? Is done roughly the same way? You can think about performance, like when the user writes code, is it going to be performant enough? Is it going to make the performance expectations? And you can think about whether you hide the implementation details. Actually, this helps you hide it. Let's consider simplicity next, right? So what is simple? How can I tell if the code is simple enough? Well, there are different ways to measure simplicity. And I picked for you the simplest one. Kind of makes sense, right? So I picked measuring conceptual simplicity or complexity. The way you do it is you take the code that you developed for a use case and you start counting the number of named constructs that you used from the API in your code sample. And you count down from 20. I don't know whether the resolution is good enough for you to see, but I started with authentication provider, assigned it a 20. Then the next one was local authentication provider, assigned it a 19. Search criteria D class, 18. Search criteria D constructor, 17. And by the time I reach authentication provider exception, at the bottom, I reach -2. So the rule of thumb with this conceptual complexity measurement is that if you start from 20, as long as you stay in double digits, your use case is simple. When you reach single digits, it starts getting complex. And when you reach negative numbers, it's time to redesign. And of course, you may ask, okay, where is this 20 coming from? Well, it's based on research. You see, when they did the usability studies at these major corporations, they noticed that there is a point of complexity where developers start failing the task. So they just throw up their hands and say, I cannot do this, right? And they started looking at those cases and discovered that at around this level of complexity, and it's not much, it fits in the PowerPoint slide, people start failing these tasks, and the number of failures goes up exponentially from this point on. So this is where this number 20 is coming from. And 20 was picked because it's a nice round number. So maybe it's not exactly 20, maybe it's 22, maybe it's 18, but you are getting the idea, right? So what can we do to actually ensure that our use cases stay simple? There is plenty of advice in various materials. And if you look at that advice, it can roughly be grouped in two big categories, depending on what kind of complexity they are addressing. because complexity can be essential complexity or accidental complexity. The definition of essential complexity would be something like this. If you do your best to figure out the simplest design for a predefined set of functionality, that simplest design represents the essential complexity of the functionality you're providing. There is just no way to make it any simpler than that. So that's essential complexity. Accidental complexity, any design that is more complex than that has some accidental complexity in it, right? So you can reduce accidental complexity by following some best practices. And there is plenty of these best practices. I have just a few listed on the slide. There is more in those articles I talked about. I am not going to go into details right now, but I would just pick one that says, for example, the last one says handle change requests carefully. So they discovered that the complexity of the API increases during its lifetime. So the more changes you make to the API, the more complex those scenarios are becoming. And they looked into it, tried to figure out why. And what they discovered was that when you get a change request, usually comes in the form of, oh, please add this method or please create this class. And that change request has actually two parts of it. One is some kind of new requirement, some new functionality people want. The other part is actually a design suggestion. By asking for a specific method or a specific class, the change request actually suggesting a particular method to implement it. And that is maybe not the simplest way of doing it. So every time you receive a change request, you always have to try to separate the requirement from the design suggestion and ask yourself, is it the simplest way to implement this? Going on to the essential complexity, as I said, this is the simplest way you can provide a certain functionality. So if the essential complexity that you get is still not simple enough, unfortunately the only way to get it simpler is to leave some functionality out. There is no other way. So you have to weigh the value of simplicity against the value of the functionality that you might possibly leave out. The good news is that not every functionality is equally important. So it's possible to find functionality that you can leave out. And I have a few examples. We always think that the caller wants absolute control. They want to have all the options open. And that complicates the API. So sometimes we can establish reasonable defaults and just don't give them the option. And that simplifies the API. We can increase the API granularity. So we can provide fewer methods and classes that do more work. Granular APIs are not as flexible as lower granularity APIs, but they're simpler to use. And when everything else fails, you can always use the divide and conquer method. It doesn't make the API any simpler, but it helps people to deal with the complexity by separating the API into well-defined parts and grouping the use cases in such a way that for a certain use case, you only need to use one part of the API and you can kind of ignore the other parts. The next thing that developers appreciate, other than simplicity, is consistency. Consistency has very simple definition. Basically, it means doing the same thing the same way every time. So, if you look at the API and you can discover some patterns and some rules and some conventions in it, by using one part of the API, you can kind of predict how the other part works. And this kind of makes the API easier to learn, easier to remember, and easier to use. Inconsistency means that you have exceptions of the rule, and these exceptions are kind of unpredictable and sometimes unnecessary. And a lot of papers I looked at use this example I have on the slide, the two functions from the C standard library, one that takes the file descriptor as a first argument, and the other one that takes the file descriptor as a last argument. And there is no real good reason why it is like this. And it kind of frustrated C developers for the last 30 years or so. So these kind of unnecessary variations is what we are trying to eliminate. How we do that? Well, there is certain simple things we can do. The first thing is to realize that a lot of established conventions in programming, which is usually specific for the language and the development environment we are using, are there especially to help with consistency. So I compare C# to Java in this slide. So C# starts all interface definitions with an uppercase I. Java does not. C# starts method names with an uppercase letter. Java starts with a lowercase. I can't tell which one is better. Nobody can. I don't think any is better than the other. This is just a convention to make code consistent. So by following these conventions, our API becomes more consistent. We can also go a step further and establish our own conventions. Two things to consider when we do this is there is no point in establishing proprietary conventions that contradict the platform conventions. So what we establish has to be complementing the platform convention. Another thing to consider is that we are trying to eliminate unnecessary variations. So if there is a good reason why things are different, then by any means make it different. Only things that are not necessary to be different from one part of the API to another are candidates for such conventions. And there are plenty of them: parameter ordering, error handling, what passing the null argument means, and so on and so forth. We are not that concerned about consistency because there is a very good tool to establish consistency, and that's code reviews, right? So if you ask a few people who are not familiar with the API to review it, they will very quickly point out the inconsistencies in the API. For very large APIs, it's usually a good idea to establish certain design patterns, like these go beyond conventions. This is how you design the classes and methods. It makes the API more consistent if the API is really big. And then one last thing about consistency is there is such a thing as false consistency. And I have this Java example where, the Java accessor methods start with get. And typically these are implemented by accessing a local field. Also the set method just sets a local field in the class. So if you create a method called getAttributes, and this method either has to do a database query, or has to do a lot of processing, or has to do a remote call, a total exception. This is kind of unexpected, because developers expect a getter to just read a local field. And there are other examples as well. This is probably the most obvious. So just keep in mind to avoid false consistency. The next thing that developers appreciate in good APIs are the names. Now, everybody kind of understands why naming is important. There is such thing as code obfuscation, where you run a code, a tool through your code. It replaces readable names with some mangled names, so people don't understand what your code does, but it still works, right? But it's unmaintainable. So names are important. And a lot of people tell developers, please choose good names. But few people tell them what good names are and actually what you can do to be good ones. And the advice that is available, again, can be grouped in two big categories. The first category I call avoid silly naming mistakes. And there are plenty of naming mistakes that you can do. I am not too concerned about these mistakes. And not because developers don't do it. They do it all the time. But because a good review process can fix these mistakes, right? So it's relatively easy to deal with from a company perspective. More difficult is the realization that some design abstractions are really, really hard to name. Abstractions are usually hard to name. So if you create a factory class that returns a builder class that can build you references to something called a document wrapper, right? Then really the best name you can come up with for this class is document wrapper reference builder factory. This is the most descriptive name. It tells you exactly what a class does. So very often, awkward names reflect kind of an awkward design. And research shows that the best names come from the domain, the problem domain. The language is used to talk about that domain. So these names, are familiar because people understand them, intuitive, accurate, and it's easy to remember. So it's helpful to think about APIs as a domain-specific extension to a general-purpose programming language. In Java, you can program everything. If you provide an API to a content management system, then you can do content management from API. So the API should reflect the domain of the content management. So it should have familiar concepts like document and folder and version and project and so on. So I'm going to show you a little example of how you can actually use this advice in practice. Assume that you want to add Web 2.0 like tagging to your content management system. So what I did here is I went to Wikipedia, I looked at the article about tagging, I copied the first paragraph, and I underlined candidates, words, terms that I could be using in the API. And then when I was asking, okay, you set a tag, I was looking at the text and said, well, the text says that you assign a tag, so maybe it's better to call it assign tag. I asked myself, what you assign tags to? And this text had the term item for it. So I used item. So assign tag, you assign tag to an item. I find that metadata helps describe an item. So I had the class describe item, that the method describe item that returns metadata, and so on. Obviously, if you just use one paragraph, maybe you are not finding the really best names, just like I did not do in this example. But if you do enough work to collect terms into your own little vocabulary, you will eventually settle on a set of really, really good and meaningful names. People don't really do this because this is not something developers do. So this is something that you have to get used to a little bit, but it really helps with naming. It really does. Okay, I'm going to make another big claim. And I will try to demonstrate that it is true. My next claim is that in most APIs, the actual behavior of the API is severely underspecified. Let me show you. I am going to show you a class. Then I am going to give you a little test. So I will show the class. I will be silent for about 1 minute to give you some chance to actually read the class definition, and then give you the test. Okay? Here you go. Okay, so here are the tests. They are written like G-unit tests. They are Boolean expressions, and the task is to figure out which test returns true and which test returns false. I will give you a little bit of time to think about it. Okay, so I hope this kind of shows what I meant. There is nothing in the class definition to tell you whether the Teams identifier class is case sensitive or case insensitive. You can guess, you can assume, maybe your assumption is correct, maybe you get it right, but there is nothing in that class definition to actually tell you that. There is nothing in the class definition to tell you whether the toString method and the getTeamsID method, both returning a string, are supposed to return the same string. You can assume that they do, but you are not sure. And definitely, when you look at the method called asTeamsArray, which supposedly breaks up the identifier into an array of strings, there's nothing there to tell you how it does it. What are the separators? Is it space? Is it dot? Is it colon? Nothing there. Again, you have to guess. Or, write it a test and try to figure it out. The same with, if you look at the derived classes, there is no way to tell whether the equals was overwritten in the derived classes or whether the equals ID was overwritten as derived classes. You may assume it was, you may assume how it's supposed to behave, but you are not sure. So what happens is that you are forced to make a lot of assumptions. And you know what happens when you make a lot of assumptions? That's right, sometimes you are wrong. So by forcing developers to make assumptions, you increasing the probabilities that you make mistakes, and they will have to spend a lot of time to discover what mistakes they made and how to fix it. And that kind of contributes to that 3 to 10 times decrease in productivity that we talked about at the beginning. So the behavior has a big part of that. So what to do about this? How can we specify the behavior? If you look at this table, if you fill in true or false for the second column, you did just like that. You specified behavior. So the best way to specify behavior is using code. So if you provide code, either as a JUnit code or as part of the documentation samples, or explicitly in the form of a table like this, you specify behavior. Developers love it when they see code. They work with the code every day. They like code better than long explanations. So instead of putting all these methods, this class is case sensitive or case insensitive, and the equals works like this, just provide the code. Show it. Don't tell it. We talked about developers making assumptions and developers making mistakes. So the next thing that I want to talk about is safety. Safety is all about the consequences of making mistakes, right? So when you think of real-life world, all the safety equipment and all the safety devices are there to reduce the chances of injury or material loss when we make mistakes. That's what safety is all about, right? So the same way in API design, assuming that developers will make mistakes, you try to minimize the harm these mistakes can do, or if you can, you try to eliminate the possibility of making mistakes in the first place. So again, there are plenty of best practices of how you can make the API safer. You don't really have time today to go through all of them. I would like to kind of pick one at random, maybe prevent the access to dangerous code. This is so straightforward, really, right? So, a lot of APIs have undocumented implementation classes or methods that are still accessible. They're public for various reasons. So if you have that, programmers may call it. And because you never intended programmers to call it, they may produce unexpected behavior. So best practice, try to keep all implementation private. The same way, if you have a class that is not declared final, and the caller extends it doesn't intend it to be extended, so probably it's pretty unsafe to do so. You are responsible for the trouble the developer gets in, right? So why do we care if the developer gets into trouble, right? Well, if they get in trouble and they waste a lot of time, they will hate the API. People don't hate themselves for the mistakes they make, right? So every time a developer makes a mistake using an API, they will blame the API. They will hate the API. So that's why we try to make it safe. There are other things. Let's talk a little bit about maximizing compiler checks. There are things, simple mistakes developers make, right? Like reversing the parameters in a method. It happens all the time. Now, if the method has 2 or 3 or 4 parameters of the same type, the compiler cannot detect that you reverse the parameters, right? You reverse the order. So maybe it's a good idea not to design methods that have a lot of similar parameters. And we see a lot of abuse of the data type string in the modern languages, C#, Java, so on. String is so convenient. Everything you can represent everything in string, really, right? But then you have a lot of methods that take string as argument. Pretty much what you do is disabling type checking. And you have to think about this, because if the string represents something that you can also represent as a class, that is represented as a class and use the type checking. So say the string is a URL. Both Java and C# has a URL object. So convert the string into a URL object as soon as you can. The conversion itself will check that the string is indeed a URL, and not a quotation from Shakespeare or whatever. And then all the other methods can be safely called, and doesn't need to do a lot of runtime checking. I have a little example in this next slide, kind of showing how this whole thing, safety kind of plays together. So I have a class that I designed for extension. The reason I picked this example is just to show you, how many safety issues come up when design class for extension. One issue that is illustrated in this particular class is that if you have methods that callers can override, the language doesn't really give you any mechanism to tell what methods can be safely called from these overridden methods, or what kind of assumptions you can safely make about the current state of the class. So in this case, I have a method on cancel that the caller can override to do some cleanup when the job is canceled. The problem is that there are a bunch of public methods in this class that are not safe to call when you are canceling the job. So in order to prevent the user from calling those methods, I have to do a lot of runtime testing. And in order to be able to tell what mistakes they made, I have to track what they are doing. So I have this canceling private method that I set to true, so I know that they are overriding the canceling method, on cancel method. And I try to make meaningful error messages. So one thing about the error messages that we have to all remember is that when the caller gets an error message, he wants to know what he did wrong. So, what I did wrong. That's what went wrong inside, right? So if I make a method call and I get a SQL exception, or maybe not directly a SQL exception, maybe a my application exception that wraps an internal SQL exception, that tells me what went wrong inside that module. It doesn't tell me what I did wrong. In order to be able to do error handling that actually tells the user what they did wrong, you have to do a little bit more work as shown in this slide. We talked about the fact that APIs are especially difficult because initial mistakes cannot be easily fixed later. But there is more to that. There's a little bit of paradox about APIs. You see, in one hand, we have to keep it unchanged because existing code relies on the fact that the API did not change to keep working. On the other hand, requirements change over time. So, if you cannot evolve the API, that's not good either. So we have to kind of navigate this narrow strait between the two constraints. There are good design patterns that you can use to make the API easy to evolve and at the same time maintain backwards compatibility. One thing to remember, though, is that we are talking about binary backwards compatibility, which means that existing client code works with the new version without being recompiled and without being redeployed. We always have to think about our biggest customers. And they may have the client code deployed in many different servers or even desktop machines. Telling them to recompile and redeploy is not going to go through very nicely. So we have to maintain binary compatibility. The issue is that binary compatibility and source compatibility is not the same thing in most environments. Source compatibility, you can check it easily. If the client code complies with your changes, then probably your changes are source compatible. Most of the source compatible changes are binary compatible, but not all of them. And the differences depend on the platform. So you really need to understand the platform and how it works to understand what binary compatibility means. And, some developers know this, some developers don't. So this is an important distinction. Some people know that C++ is very bad when it comes to backwards compatibility, especially because, various C++ compilers do things differently. So if you have a multi-platform C++ code and you want to maintain backwards compatibility, that's really hard. That's why a lot of APIs are written in standard C. That's a bit better. Java is even better, but even in Java there are things that, people are surprised. If you do, for example, constants, you add constants to your API, and then you change that constant later, you'll be surprised that the client code still uses the old value. And that's because the Java compiler puts the value into the client code as part of the bytecode optimization. Things like that. Functional compatibility, I'm not going to talk a lot about this because that requires a little bit of, introduction about what preconditions, postconditions, invariants mean, and what is weakening, what is strengthening. I just want to point out that you can break the client without changing anything in the code of the API by just changing something in the implementation. So, because behavior is usually underspecified, the developer of the API and the client of the API, none of them are quite sure what the behavior should be. So there is a lot of potential to subtle behavior changes, involuntary behavior changes, that will break the client code. So having a good set of unit tests is very essential if you want to maintain functional backwards compatibility. And one other thing to remember is that SPI, service provider interfaces, the things that you provide for the clients to implement so that they can plug into your framework, or callbacks that you provide, evolve very differently from regular APIs. A lot of things are quite reversed, right? So if you can weaken preconditions with APIs, you can only strengthen preconditions on SPI and things like that. Another thing to keep in mind. The next thing, and this is very important again, is that you probably cannot continue evolving the API and maintain backwards compatibility forever, right? Just like, the way hardware evolves. So if you had devices that had serial ports, today the same devices take USB cables. So there are major disruptive changes in technology or in the requirements that require you to create an entirely new API. And we call this API versioning. So the idea here is that it has to be planned, and it has to be in such a way that there is an incentive for the customer to upgrade. Because if there is no incentive for them to upgrade, then they won't upgrade, because the upgrade requires them to change their code, it requires effort, it requires time, it costs money. So if there is no incentive, they won't do it. So you will end up with a customer base that use different versions of the API. You end up maintaining all these different versions of APIs for a very long time. So it's better to have this major change done in such a way that you have a lot of new functionality. Use this opportunity to clean up and reorganize the API, so you establish some of the quality that's degraded over time. And you know how we can never remove anything from the API, only deprecate because somebody might be using it. So when you get a new version of the API, this is your opportunity to remove the deprecated functionality. Why? Well, the old API will be still maintained for a while. So it coexists with the new one. And usually the way we do this is to create a kind of adapter that re-implements the old API on top of the new one. This is a better approach than maintaining two different implementations from scratch, because that creates a lot of maintenance work. And it creates a code bloat. So the whole module or application is much bigger now, having two independent implementations. So usually you have one implementation, functionality exposed to the new API, and then use something like this adapter cable to connect with clients that still rely on the old API. And finally, we reach the topic of documentation. So you remember we talked about the APIs being documented interfaces. There is a lot of opinion you hear when you talk to people. And I have a few of them on this slide. So people say, oh, I don't need documentation. My API is self-documenting. I think this opinion is false. I already showed you that the behavior is usually not self-evident. So unless you provide some kind of documentation, people will have to do all kinds of assumptions about behavior. But there are other things that need to be documented as well. Then people tell me that nobody reads the documentation. And this is actually true. By reading, we mean reading like a novel, starting the documentation at the first page and reading everything until you reach the last page, then yes, nobody reads documentation. Because there are a lot of APIs the developers need to use. They are big, so they don't have the time to learn the whole API before they start working. So what they do is they learn enough to get started, and then they use what they call just-in-time learning. So every time they have a question, they go and reference the documentation. The issue with writing the documentation so that it can be read is that certain information may not be found if it cannot be quickly referenced. So if you need to read through a chapter to find out about something, you cannot easily find it using the index or the table of contents or a hyperlink or something, then you won't find it unless you read the documentation, and you won't read it, right? So this is something to keep in mind. Then a lot of people take this nobody reads the documentation to mean that nobody needs or nobody uses documentation. And this is absolutely false. And there was this little experiment conducted by Adobe. They looked at who is using the online help for the Adobe Flex product. They measured access during the month of July 2008. And there were over 24,000 programmers, individual programmers, who accessed the site. And they made over 100,000 queries. And this was the lowest number for a month, being July and summer and everything. So people use the documentation. It's just they don't use it as we think they use it. Some people say, well, we asked developers if they want more documentation. They said no. So people don't want documentation. And this is actually true. So developers don't want documentation in the terms of they don't want like a big book or a big PDF that contains everything. What they really want is help, right? They want to be able, when they get stuck or if they have a question, they want to be able to get the answer quickly. And the best way to see that is to look at the online forums. So I looked at the stackoverflow.com, which is a developer forum, very popular. And there the questions and answers are ranked by users. What was the most helpful question? What was the most helpful answer? But the one that I have here is one of the most helpfully ranked one from that site. And if you look at that, the question is very simple. It says, well, I am using the Java SQL resource set class, and I want to display the column name using the column index. I looked at the class, I cannot find the method. So he asked the question on the forum, how can I do it? And the response comes back and says, well, see resource set metadata, meaning, no, it's not in resource set, in resource set metadata, and it has 3 lines of code to actually show how you do it. So the reason the question was rated one of the most helpful is that a lot of people are having the exact same problem. Because when you display a result, you're using this resource set class for everything except the column name for which you have to get this resource set metadata thing. So it would be much better if the get column name would be actually part of the resource set class, but it isn't. So it's a problem for a lot of people. So that's why the question is highly rated. The answer is highly rated because it's just one word, C, and then the rest of it is code. So it's very helpful because it tells the developer exactly what they wanted to know. So if you look at these forums, you will learn how to provide helpful documentation. And it's all about a little bit of role playing. So you have to imagine that you are a friend answering questions, providing assistance to the developers. You should try to anticipate what questions they have, and you provide the answer to those questions. So what does it mean in concrete terms? Your documentation would be mostly of short sections, answering specific questions. These sections would be very easy to find using the just-in-time learning and referencing. And you will use a lot of code samples because you know that developers love it. Now, we won't have time to get into the various types of developer documentation. I have a list here on the slide. Some forms used to be popular and getting less popular nowadays. So when I started programming, everybody had the Kit developer guide on their desk. Nowadays, because so much information is online and you can Google it, the developer guide is a little bit out of favor. Very, very popular, and you can see this in Amazon.com if you search on the software books, the cookbook format. So the cookbook format is pretty much a collection of scenarios and use cases and code samples to show how you do that. So a series of questions, how do I something? and then a little code snippet to show you how we do that. It's very popular. Other thing that is becoming popular are video tutorials. So again, you can Google it. You can just search for video tutorials for your favorite programming environment. You will find quite a few online. There are tools that make these tutorials relatively straightforward to create. And finally, FAQs are popular because they are online, they are quick to update. So if you discover somebody has an unanticipated difficulty with something, you just add it to the FAQ or the knowledge base. So we are pretty much out of time. I would like just to make a quick summary. As I said, this is a high-level overview I wanted to share with you today. And I really just want you to remember the basic ideas of the API design. And these are, one, to consider the perspective of the caller, which means think about the code the caller will have to write for a particular scenario. To keep it simple, to make it consistent, to spend time to find the best names you can, to make sure that the behavior is clearly described, if possible using code samples or unit tests, to spend the time to make the API safe to use and provide meaningful error messages that actually tell the caller what they did wrong, not what went wrong inside, to make sure that you can evolve the API over time, and to make sure that the documentation you provide is helpful to the developers. Now, although we couldn't cover the details today, I have the series of articles online. They are called API Design Guidelines. I'm sharing the URL right now. You can go in early and you can read up on these specific topics. The guidelines are organized based on the way I organize presentation. They're about 4 pages in length. It takes less than an hour to read every one of them. And they have hyperlinks to external resources. So if you really want to go into detail, then you can click on those links, and there is plenty of reading material for you. And I think we are done. Thank you very much. I think we can open it for questions. Then I don't know whether we should stop the recording at this point or continue recording.